Okay, welcome back, Art22. We are in the second part of our mini-series here on learning about the class. And we'll be using the class in most, if not all, of the sketches going forward. But we need to now kind of take things one step further. So in the last lecture, we looked at how we can basically create the idea of some object, like a rectangle, a human we saw, or a particle, and make basically a template for that object in the form of a class. Then, when we want to create one particular instance of that class, we just use that constructor that we learned about last lecture to create a new version. So for example, we had a class called human, and we made one instance of that human named Mark. And so we used the human constructor with the parentheses and gave it that information that it needed, the name, the age, and the amount of coffee, as we saw. So here's the deal though. We made one other example of a human class, and then we made two examples of the particle class. Now, what a theme that we've seen throughout this course is that we always want to be looking for ways that we can reduce the amount of lines of code we're writing to get things to be more and more complex. So if I wanted 100 humans or 100 particle classes, doing that constructor line 100 times separately is definitely not the way to go. So we're going to learn today how we can use loops to make that happen. And you're going to see that as before, with less code, we're actually going to get much more complex and some really interesting results today in the code that we're writing. So let's do first thing today, which is let's convert our sketch from last time. We'll save it as a new sketch, and we're going to tweak a few things about our particles just to get set up for how we're going to make a whole collection of particles today. Okay, so let's do that thing first. Okay, so this is the sketch from last class, week 5, class 1. What we want to do is save this as a new sketch. Save as week 5, class 2. Great. Now, let's just do a few things to clean up here. We are just going to go ahead and get rid of the entire human class here, which sounds like a very dramatic thing, right? Like deleting all humans. Okay, so we're going to delete that tab. Yes, we're sure. Now let's just delete the parts that are involved with the human class. Great. We can get rid of this here. We can get rid of this here. So we should be left with just our particle class that still has a XY position, a size that we'll use for our point, stroke weight size, and then a speed for both the X and the Y direction. And if we run this, we should be seeing two particles that have different starting positions. And if you remember from last time, the size of particle Q would get bigger when I click the mouse. So let's just take a look at that, just to remember where we're at. Okay, Q went away too quickly. Let's just try one more time. There, see it getting bigger. Okay, great. So before we even worry about getting new, before we end up getting collections of these particles and making big lists of them, let's go ahead and just tweak a few things about the particle itself, and then we'll make a collection of them. So the first thing I want to do is I don't want to worry about these particles floating off the screen like we saw when we just ran this sketch. So what I'm going to do is implement a version of something we saw in week 3, which is creating this idea of boundaries, so that the particles will be bouncing off the edge of the wall if they get to that edge. So this is same idea as we did in week 3, but just a slightly different way to go about it. Basically, the gist of it is that we're still multiplying our speed by -1, so that basically the sign reverses. So if we're adding positive speed, then we multiply by -1, now we're subtracting speed. So that's basically how it works. So if that's something you need a refresher on, go back to week 3 and maybe take a couple looks at the code example from that week. So let's just put it into our class. So this is going to be part of our display function here. So this is going to be, let's say, check for boundaries and reverse direction if at the edge, let's say. Okay. So what we're going to say is if x, so the position of our particle, if x is greater than or equal to width, or if x is less than or equal to 0. So this is saying, if our x position is past the right edge of our screen, width, or it's 2 vertical lines here, or if it's off on the left side of our screen, so less than or equal to 0, what we would like to do is take our speed x and make it and multiply it by -1, so times -1. So that's going to reverse the direction of our x speed, and it'll start going back the other way. Now let's just do the exact same thing for y. So if y is greater than or equal to height, or if y is less than or equal to 0. Same deal. Oops, too many spaces. Speed y is equal to speed y times -1. There we go. So that should reverse our direction for us. Now let's run the sketch again and just make sure that our particles are now bouncing out the walls. There we go, good. Now we can increase the size of that one with our interaction. You can imagine many 2D games could come out of this. Okay, good, so that's working like we want it to, great. Okay, so now the time has come to think about how we are going to make multiple examples of our particle. So let's check in with the other screen here. Okay, so in the same way that when we wanted a collection of items, maybe like a collection of numbers or integers, floats, letters, images, any of those, we used an array. Okay. We are going to use a different kind of array to store all of our particles. So it's called an array list. It works very similar to an array, but it has some really nice properties to it. First, we are able to dynamically add and subtract items from the array. So from the array list, I should say. So if you remember, when we would make an array before, we had to tell it how many elements we wanted in the array. We'd say something like new int square brackets 30. So we'd have 30 numbers in our array. And that's just kind of how it was. With an array list, we can create one and it's basically empty. But then what we can do is we can add things to the array list as we go. And we can also subtract things from the array list as we go too. So this makes it way more flexible. And we're also going to find that the language in processing for how you add and subtract things from array lists is actually a little bit more intuitive. We say things like add or remove and things like that. So it's a bit more clear, I think, in the code how it's working. The only, I think, tricky part really is some of the syntax for how we set it up in the top of our sketch and how we loop through an array list. So we're going to do it slightly different than the for loops that we saw for an array. We're going to use a different kind of loop for our array list. But we will definitely get used to them because we'll be using them a lot for the rest of the course. So let's go ahead and make an array list that's going to store all of our particles. And then we'll see how we can run them, as many as we make altogether. Okay. All right. So what I'm going to do is I'm going to come back to our top of our screen here. So now what we want to do is we want to create an array list to hold many particles. Okay. So this syntax just to create an array list is a little wonky, but luckily it never changes. So once you've done it once, you can always just go back and reference what you've done before. So we say array list turns orange. We're looking good. Okay, so now just like when we made an array, we need to tell it what type of thing is going to be inside of this array. In this case, this array list. Well, the name of our class, the type of it is a particle. That's what we made. So that's what we want to have an array list of. So you could have an array list of floats or images, but we want an array list of particles. Now we just need a name for it. So just to like maybe keep it a little bit intuitive, I'm going to call our list of particles the P list. So P for particle, P list. Okay. So now we have an array list of type particle called P list. And now the rest of this is a little redundant, but it's just the way it is. There's a new array list with type particle and then parentheses. So yeah, a little weird looking, but it gets the job done. So this has just given us an array list called plist. Very cool. So now if we wanted to add particles to this, we can actually kind of bypass this idea of needing to define individual particles first and setting them like this. We can do something a bit more clever. So what I'm going to do is I'm going to comment these out for the moment. So what I'm going to do is come down here and I'm going to say plist dot add. So we're adding a new particle to the plist. And now what we do is we just give it this half of the equation here for when we're creating a new particle. So I'm just actually going to copy that, put it here. Need one more parenthesis. So what have we done? We've said, okay, we have our plist, our collection of particles. And we're going to add a new particle that starts at x equals width divided by 2, so in the middle. Y equals height divided by 2, middle. Has a size of 10 pixels and has a speed of 2 in the x direction and 1 in the y direction. Now we've added it to that particle list. Great. Now we would need then to run its display function in here, but let's get to that in a minute. Actually, you know what? Let's get to that right now. So the way we're going to do this is with a new kind of loop, because we're going to keep adding more and more particles. Maybe we've removed some. So we just basically want a way to say, hey, however many particles we have in plist, it might be 1, it might be 1,000. We might not even be sure at some points. We just want some function that's going to say, hey, go through every particle in our plist and run its display function. Because remember, that's what we actually use to see things. It's this part here. Yeah, format that better. Okay, so this display function, that's the thing that's actually showing us stuff. So we basically want to say in pseudocode, like, for every particle in the plist, run its update function. That's what we want. And luckily, there's actually a really great version of a loop, a for loop that does this for us. It looks like this. So we say for Now we have to tell, this is a little bit weird looking, but we have to say particle, because that's the thing we're dealing with. So for particle P, let's say, so this is like a placeholder. This could have been anything. This could have been pizza. Doesn't really matter. But because it's basically kind of like in the class when we had placeholder variables here, same idea. It's kind of a placeholder for the name of our particle. So for particle, let's call it P, colon, plist. Let's put some curly brackets. So this line of code right here says exactly this part of it. It says for every particle in the plist. In fact, let me even put this here, so we know this is exactly what is happening. For every particle in the plist. Now what do we want to do? We want to run the update function, so we're going to use this placeholder variable. We're going to say p.display. And that says run its update function. So we'll get rid of these old ones. So you can see it's the same as this, right? The difference was in our previous version, we created a single particle, named it P, like gave it its actual name as P. We created a new particle with the constructor for the particle P. And then we said, because it's like official name, p.display. Now we're doing it with this loop way where we might have 100 particles in our plist, and we're just using the letter P as a placeholder for its name. So I'm going to get rid of these. And just to keep things, I'll keep these up here too, but I'll just comment them out just so we can look at them for reference. Okay, so if we run this, what we should see, get rid of this too, is that we've only added one particle to our plist, but because this loop is going to go through all the particles, it should run the display function for this one particle we added. Let's check it out. There it is. There's our one lonely particle bouncing off the walls because that's what we told it to do in the display function. Great. Okay, so here is where things get kind of fun. What happens when we want a whole bunch of particles? Okay, so what we're going to do is we're going to use a loop up here. And so let's say what our goal is. We want to add some number of particles to the list. Let's say, maybe so we can control this later, I'm going to make a variable called total. And I'm going to equal 100, let's say. How about even 1,000? Why not? Yeah, let's keep it 100. So this is total number of particles that we want. Okay. So we want to add total number of particles to our plist. Well, this here gives us 1, so we're 99 short, okay? So we know from past lectures that the way we can do something over and over and over again is with a for loop. So we're going to use our very standard for loop that we've seen before, the very first one we learned, to make this happen. We're going to say for int I, this should look very familiar at this point, while I is less than, so we need it to go up to 100, we've defined that variable total. So while I is less than total, I plus plus. It's the same loop structure as always. I'm going to put our other curly bracket here. I'm going to do a command T to format this. Excellent. All right, so what this should be doing now is we're adding a new particle 100 times. However, I'm not going to run this quite yet because one thing that kind of isn't great about what we just did is this is all the same, right? Like every time it's going to start in the middle, it's going to have the same size and the same speed. That's not exactly what we want, right? So let's do this. Let's say that we want it to all be the same size, but we want each particle, every time we add a new one, to have a random speed, let's say. So I'm going to say random, how about from maybe -2 to 2. This is our x speed, remember, this part. And then this will be our y speed. I'll do the same thing, -2 to 2. Okay, so let me put a comment here. So add new particles with a random speed x and speed y value. But they're all going to start right in the middle. Okay, so let's see what we get. You know, and also I'm kind of sick of this boring background. I'm going to make a couple changes here. I want to make this 198. I happen to know that this is the color I like. 91. And then let's make the stroke of this particle. Let's go with, why don't we go with black instead? How about that? Okay. So we have now stroke color black, and we have a more interesting background color. That's just purely aesthetic, but I'm tired of the black and white backgrounds. There they go. So this to me is very cool because now what we've done is we've taken a simple, well, maybe not a simple concept, but we've taken something that was easy to make one of, right? Like we made a class, it was a particle, we made one example of it. Now, just by basically adding the for loop in here, we've now made 100 of these that are all behaving similarly, but they have their own differences, right? They all have their own speed. And my computer is working very hard today. I'm not sure exactly what's going on, so sorry for the lag here in running this code, but hopefully on your machine it'll be running more smoothly. But to me, this is like we've kind of leveled up in terms of complexity of the type of environments we're creating, which is very, very exciting, I think. Okay, so just to illustrate this point a little bit more, I'm going to say, what if we want 10 particles? All we have to do is change that total number. Let's run this again. There they go. They all have their random starting point. I'm sorry, they all have their same starting point but random speeds. Great. Okay. All right, so we've got a particle. We have a kind of behavior. We have now made a loop that makes as many of them as we want. Let's go back to 100, I kind of like that. And we have a new kind of loop that goes through our entire array list of particles and tells them to be displayed. Okay, so now what we're going to do is we're not going to add anything new in terms of stuff about the class, but let's just make something kind of interesting with what we have already learned about the class in these 2 lectures. So first things first, I want to add the idea of there being like a lifespan of our particles. So instead of having them hanging around forever, I want them to slowly maybe like fade out over time. So what I'm going to do is I'm going to come back to our particle here. And I'm going to introduce this idea of having a variable called lifespan. And this can just be an integer. Lifespan. And I'm going to set it equal to 255. And this might give you a hint about how we're going to go about this. So what I'm going to do is I'm going to use this variable lifespan to be the alpha channel of our point in our stroke color, so that when it starts at 255, it's not transparent at all. But then we're going to over time decrease this lifespan variable by 1 or by some amount, and that's going to basically make it more and more transparent, which gives it the result of fading away. So let's just take a look at how that can work. So I'm going to say stroke color now is black, but with lifespan as the alpha channel. Oops. So lifespan is the alpha channel. Okay. And then what we can do is maybe after we draw the point, we'll say something like this. Lifespan minus minus. Excellent. So with that, the result of that is going to be every frame of our animation, so every run through of our draw section, lifespan of these particles will get less and less by 1 until they're invisible. So let's check out the result of that. There they go, fading out. Now, we won't do this today, but you could set up something where you had maybe a conditional here that said, you know, if lifespan, or maybe actually probably best to do it here, but you could say something like, you know, if lifespan is less than 0, so if it's fully invisible, then we remove it from our plist. But I'm going to let you look into that if that's something you're interested in. The reference for Arraylist shows you all the functions you can use on an Arraylist. So we saw the add function. You can see all the other ways that you can change an Arraylist. Okay, great. Now, let us do I guess 2 other things with our Arraylist classes today. Let me switch over to the other screen for a minute. Okay, so let's think through basically the steps of what we've done so far. So we created the idea of a particle, a dot that's moving around the screen. We gave it some bouncing characteristics. It now has a lifespan, so they fade out over time. There's a starting position, has some speed. Then we took that class and we learned how to make one of them. Cool. Or we make one at a time with our tedious way of saying, you know, from the last lecture. Now we've learned how we can have a list, an array list, maybe called plist, where we add as many particles to that as we want, and then a loop that will go through the entire list and run the display function for every particle in that list. That's why we're seeing all of them move around. Okay, so now what I want to do is 2 things. First, I want to treat the particles more like a brush. Like if you remember from early in this course, we looked at how to draw things dynamically, right? Maybe changing the color based on where the mouse is or something like that. So what we're going to do is we're going to take this system that we have with a bunch of particles moving around. And instead of just having it like a static thing, they all start in the middle and they all kind of diffuse out and bounce around and fade away. We're going to make it so that the particles are kind of like a brush. Then the last thing we're going to do today is we're actually going to make a second class, a different particle, and put them together and just see some of the cool complex results that we can get from something like that. So let's first learn how to make this into like kind of a brush, so it's kind of interactive, and then we're going to add just one more particle that is only slightly different from the current one that we have. Okay, let's give that a go. Okay, so what I said is that I want to, instead of having all of our particles start, for example, right at the beginning and start at width divided by 2, height divided by 2, I want to change that so that if basically the goal is going to be if our mouse is pressed, we'll draw with a bunch of particles, but if not, nothing will happen. So here's how we're going to do that. I'm going to come down into my draw loop. Let's just put this at the bottom here. So what I'm going to say is if mouse pressed, so if I'm holding down my mouse, for example, I like to call this a particle emitter. I think that's how you spell it. So this is going to be kind of like our little like particle gun kind of thing that's like spraying particles everywhere. Okay, so what we're going to do is take this line of code gonna copy that. And now I'm gonna put it in here where our mouse is being pressed. Now I want to change a few things. First of all, I'm going to comment this out. So we're not going to have any particles at the beginning. I'll leave it there because it's kind of fun to see that, but we're going to cancel that out for the moment. Now what I want to do is say, oops, I think I spelled mouse. Mouse press, not mouse. Mouse press. Okay, so now what I want to do is I don't want them to start in the middle. I want them to actually start where my mouse is. Because I'm having mouse interaction, I might as well use the mouse kind of fully here, right? I'm going to keep the size the same. I'm going to keep the randomness of the speed the same. Cool. So let's see the result of this now. Okay, so nothing. Aha, there we go. So now we basically have this brush that is a particle generator. Again, you can imagine this, a sort of souped up version of this exists in a lot of like the special effects you might see in everything from, I don't know, even like CGI movies to video games to interactive art pieces where things are like motion tracking. Like there's a lot of possibility with this kind of thing. Okay, very cool. So now we've just basically gone from a static way that a certain number of particles are generated at the beginning and move around. So now we have this interactive particle emitter that is kind of like a drawing tool. Okay, so the last thing we're doing today is we're going to actually make a whole nother particle. Luckily, we're going to be able to copy and paste most of it, just to see another example of how this could all come together. Okay, so I'm going to come over here, and I'm actually just going to grab this entire particle. I'm going to hit Control A, or whatever operating system you're on for select all, or you can just drag and do it, whichever works for you. I'm going to copy it. I'm going to make a new tab. So we're going to make a particle that is like our random walker that we saw before, I believe in week 3. So I'm going to call this particle a walker, named after its random walk algorithm. All right, I'm going to paste that in there. All right, so we need to make a few adjustments to make this particle change into a random walker. First things first, we can't have it be the same name as our other particle. So I'm going to change this to Walker, not to be confused with Texas Ranger. I'm dating myself here. All right, so Walker, class name is Walker. We've now changed our constructor to match. Great. Now, we basically just need to make a few changes to make this from like a particle that's moving based on some speed into our random walk algorithm. And I'm going to go through this relatively quickly because we already covered this in previous lectures, but what I'm going to do is I'm going to say that basically I don't want to have x be equal to x plus some speed, but we want to have it equal to some randomness, right? That's how walkers work. So now what I'm going to do is I'm going to say x equals random. Let's just say we want to go from -3 to 3. So that's like our step size. Our pixel, if you remember our chessboard, right? It can go from, our x can go up into 3 pixels to the right or left 3 pixels. Now we'll do the same thing for y. Oops. Y. Oops, I should be doing x equals x plus that. Y equals y plus random -3 to 3. Great. So now we've changed our x and y by adding a random number between -3 and 3, which is going to give us that kind of jittery random walk behavior. And because we're not dealing with speed x and speed y now, and because we have lifespan where they're fading out anyways, I actually am just going to get rid of this whole boundary thing because it's not going to be really that important for the random walk particle. Okay, excellent, excellent. Now, we could just make life more simple for ourselves and kind of clean up some of this. Like for example, we don't need speed x and speed y anymore. So I'm just going to get rid of those. Unnecessary. We do want size still, so we want x, y, and size. We can get rid of these here. And we can even get rid of where we define them. So we just really have x, y, a size of our particle, and then we're adding our randomized steps to it. Okay, very cool. So there's our walker particle. Now what we're going to do is basically repeat the process we did for the particle, but now with the walker. So I'm going to make an array list for the type walker. So this is going to be the list that will hold all of our instances of the walker. Okay, and I'm going to call that W list to kind of keep in with the theme of how we named the other list. And then the kind of repetitive part. Array list, walker, parentheses. Okay, so same exact thing, but just using the new class that we just created. Great. Now I'm going to make this, I'm going to bypass the idea of having a bunch of them at the beginning. And I'm just going to go straight to our particle emitter idea. And what I'm going to say is, if our mouse is pressed, we are going to add new particles to the W list this time. So we're going to say W list, our list of walkers, dot add. Make a little room. Okay. So what this is going to be is we're going to add, what do we want to add? Well, we want to add a new walker. And remember, the walker needs three things now. It needs an X location, a Y location, and a size. Well, that's easy enough. X location, we still want it to be our mouse because this is our kind of brush tool. So X and Y. And then, sure, let's just keep it 10, why not? And then we need one more parenthesis. We should be good to go. Now, I do want to change one thing about the color. Let's just to differentiate them. Let's make this, the walker white, the particle black, and that should help us see the difference. Okay, and now the last thing, we've added, or we're adding walkers when we press the mouse. Now, just like we did with the plist and doing the display function for all of our particles, same thing. Actually, I'm just going to type it out to get practice here. Same thing for our walkers. So we're going to say for walker W in W list. So for all of the walkers in our W list, so our collection of walkers. Think of them as like little creatures or something. So for each of those, what we want to do is say run the display function. Great. Let's see what we got. Cool. So everything's still fading, but now we have this behavior of kind of the jittery walkers that are all hanging out because of their random step size. But then our old particles are still doing their kind of traveling idea here where they're hitting the boundaries and bouncing around. So this is that final example just to show you that with two very, very similar particles, right? Not much was changed between the two of them. We now have a pretty rich sketch in like particle systems. So that's what this was called, a particle system. We now have this, and if you think about it, after we wrote our classes, we really only wrote, like less than 40 lines of code. So it's actually pretty efficient. So this is something you can run with. You can really give a lot of variety. You can imagine having 4 different classes that all did slightly different things, but they're all interacting together. And yeah, you can just kind of take it wherever your imagination wants to go with it. So that is it for the class, at least in terms of learning about it, but we'll keep using it quite a bit going forward. And as always, reach out with questions or comments, and we'll see you next time.